All right, guys, we're going to look at half, double, and triple problems today. So I gave you the formula for half-life. They could also just say that this is y equals a times 1/2 raised from your time divided by your half-life. So if you like it written better like that, you can. So number one, it says the half-life of chromium-51 is 28 days. The sample contained 510, and they want to know how much chromium would remain after 56 days. So I know that my starting amount, or that initial amount, was 510. So y equals 510. If it's a half-life problem, the number in your parentheses is always 1/2. Now, the total amount of time that they gave me was 56, and then I'm dividing it by my half-life time, which is 28, because I got to figure out how many times is this actually going to half in the total amount of time that they gave me. So sometimes that will simplify. 56 divided by 28, it gives me 2. So I could say 510 times 1/2 raised to the second. And then you just got to plug that into your calculator. And I get 127.5. Okay? Now, the next question says how much would remain after 1 year. The process is exactly the same, but notice that your half-life time is in terms of days and the total amount of time is in terms of years. So you have to figure out how many days is in a year. Well, I know that there are 365 days in a year. So the only thing that's going to differ is this total time number is now going to be 356. And I'm going to squeeze this in red. So I would say 510 times 1/2 raised to the 365 divided by 28. If you don't want to simplify that fraction, when you go to plug that into your calculator, when you raise it to the exponent, you need to make sure that you put the exponent in parentheses. And I get 0.06. All right, if I look at number 2, it says iodine 131 has a half-life of 8 days, so I'd probably highlight that. The sample started with 2,000, and it wants to know how much would remain at the end of 32 days. So my starting amount was 2,000. I have a half-life problem, so it's 1/2 in there. My total time is 32, and I'm dividing it by my half-life time, which is 8. And I know that that's going to simplify to 4. So plug that into your calculator. And I get 125. Okay? If you look down at your doubling, the only thing that's different is instead of writing 1/2 in your parentheses, you're writing a 2, okay? So number 1, it says that termites are taking over your house. There's originally 10 termites, but they're doubling every hour, and it wants to know how many termites are there after half of a day. So I know that my equation would be y equals my starting amount, which was 10. Inside my parentheses is a 2 because it's doubling. My total time is after half of a day, but my doubling time is in terms of hours. So we have to figure out how many hours are in half a day. Well, I know there's 24 hours in a whole day, so half of a day would be 12. And I'm dividing it by 1 because it's going to double every hour. So really, it's 10 times 2 raised to the 12th. And I get 40,960. All right. The next one, a bacteria culture starts with 1,000 bacteria and doubles in size every 3 hours. Okay, so we start with 1,000. We double, so there's 2 in our parentheses. It doubles every 3 hours, and they want to know how many bacteria will be there after 2 days. Well, remember, we have to have the same category for our time. So 2 days would be 48 hours, and I'm dividing it by 3. Which I could say it's 16. Okay, so if I plug that into my calculator, I get so 65,536,000. Okay. If they gave you a tripling problem, you just have to change your 2 to a 3 inside your parentheses. So a mold population, it triples every 90 minutes. There's 2 mold spores when you start, and they want to know how many there are after 6 hours. Well, every 90 minutes, if I change that into terms of hours, it would be an hour and a half. So I would say 2, it's tripling, so 3 is in my parentheses. My total time is 6, but I'm dividing it by my triple time, which is 1.5. So if I plug that into my in my calculator, I would do the 6 divided by 1.5 in parentheses, and I get 162. The last thing I want to look at is if they gave us a function and they said, tell if it's growth or decay. So remember, if you look at the number inside your parentheses, if it is bigger than 1, you know that it is growth, okay? So my growth was y equals a times 1 plus my rate raised to my time. So if this number right here is greater than 1, it's growth, okay? If it was decay, it would be 1 minus my rate raised to my time. So the number in my parentheses would be less than 1, okay? So just look, in the first one is 1.08. It is bigger, so it's growth. In the second one, 0.96 is less than 1, so that would be decay. The third one is growth. And then the fourth one would be decay, okay? Now to figure out what the actual rate is, what I would do, you know that 1 plus my rate equals 1.08. So really you could just subtract 1 from both sides and you get that your rate is 0.08. Remember, this is as a decimal. So to get the rate as a percentage, you're moving your decimal place 2 to the right this time, and I get 8. So that would be 8%. Now, if it was a decay problem, I know decay is 1 minus my rate equals 0.96. So honestly, in my calculator, I would do 1 minus 0.96 to figure out what they subtracted. If I do 1 minus 0.96, I get 0.04, and I know that 1 minus 0.04 really does equal 0.96, okay? So the rate was 0.04. If I move that 2 to the right, that gives me 4%. If I subtract 1 from 1.28, I get 0.28, so that would be 28%. And if I do 1 minus 0.77, I get 0.23. So I know they had to subtract 0.23 to get that 0.77, so that would be 23%. All right. Let me know if you have any questions on half, double, triple, or identifying what the